good morning, everyone. I'm Amy Parsons, the Communications and Event Director at Ocean Energy Europe. Apologies for the slight technical difficulty at the beginning there, but I'd like to welcome you all to today's MaRINET2 project webinar, which is about the virtual access service offered through the project. I'm going to let the presenters go into a bit more detail about what that involves, but I'm just going to give you a quick overview of who's speaking today, and I'll also tell you how you can ask questions to the presenters. So we'll be starting off with Christophe Maisondieu from Ifremer. He's going to be giving an overview of the MaRINET2 project and also the virtual access service, a bit of a summary of how that can be used. He's then going to go on to talk about the Homer database, which you can access through the virtual access service, and then the other presenters will also be going into a bit of detail about the services that they offer. So there's Javier Sanz Rodrigo and Paul Gankarski from the Sena Foundation, and they'll be talking about the WinBench benchmarking service, and then finally we'll have Lars Setran from NTNU, and he's going to be talking about the Skipir Met Station and the data that you can access from that. So you should be able to ask questions throughout the webinar through the GoToWebinar control panel that you should have on your screen. There is a questions section on the panel, and you can just type your questions into that for the presenters, and I'll be putting those questions to the presenters after each presentation, and then we'll also take some time at the end if there are additional questions coming up. So you should be able to see on the screen there where you can ask your questions. We're not going to be taking audio questions, partly because there's a large number of people online, but also it's just easier to manage in case we have duplications and so on. So that's the summary of how to use the software. The webinar is being recorded, and so we will be able to send a video recording of it around to everybody who's registered after the webinar, and we'll also put that on the MaRINET2 website in the next few days. So if you have any colleagues that you think would be interested, then you can also share that with them. Okay, so I'm going to pass over now to our first presenter, who's Christophe Maisondieu, as I said, and he's going to be introducing a little bit the project, the MaRINET2 project and the virtual access service, and he's also going to take you through the database that Ifremer can offer through that service. So, Christophe, if you're there, I'll pass over to you.
Okay, thank you, Amy. Good morning, everyone. So I'm Christophe Maisondieu, and I'm the coordinator of this MaRINET2 Virtual Access program. So you probably know a little bit about the MaRINET2 project. This is an H2020 European Commission funded project. The main objective of MaRINET2 is to support the development and deployment of offshore renewable energy systems, mostly through testing at different facilities, whether it is labs or open sea testing sites. But also we conduct research through the program, and we also offer this virtual access program, which we are now going to describe and to present to you this morning. The virtual access, we're just going to go through rapidly the different points. What is virtual access? Who is eligible? How to apply, which is important. You will see that it's really easy to apply for access to this service, and just say a few words about the requirements when using the data sets and the services we provide here. So as you may know, if you've been on our website, we offer 3 services in this virtual access program. One is a Wave Hindcast database, Homer. The other one is WinBench, is a verification and validation platform. and we also have the data sets provided by the Skifeya Met Station. So we will in the second part of this presentation, we will go into the details of these three services, and we will take your questions on this as well. So what is virtual access? So virtual access is something that is offered in all the or most of the H2020 projects, and the objective here of this service is to offer free of charge access to e-infrastructures. So e-infrastructures, they cover different services like computer services. You can have access to powerful computers, networks, data banks, different databases, different storing services, and also you can have access to operational communication services. So there are different kind of services that are available through virtual access in the different European H2020 projects. But in our case, in the MaRINET2 Virtual Access Program, we mostly have databases to offer. We offer access to environmental measurement or INCAS databases, but also to this model validation service that is the WinBench service. Sorry. So the question, who is eligible for access to MaRINET2 virtual access services? Actually, everyone is eligible. There is no limitation here. The services are available to all users from the European Union and from countries that are not part of the European Union, and it's a fully open and free access. To apply, it's also really simple. I would say that the easiest way is to go to process in 3 stages. As there is no selection procedure, you can actually apply at any time over the whole duration of the project. Or actually, the MaRINET2 project will last until late June 2021. But just to allow you to access the data and services over sufficiently long duration, we will welcome applications only until March 2021. The applications are not meant to be really evaluated, but they will still be assessed by the manager of the services to which you request access, just to make sure that the services he's offering is matching your requirements, and that it will be able to provide the information or the data that you need. That is the only kind of assessment we will conduct on the application and on the use made of the data or of the services. So this is really important, and a really important point. You can access at any time. You can apply at any time, and usually once you have applied, the access to the data is provided in a really short time. I mean, without real delay, maybe a couple of weeks, well, depending on that, on your requirements, but it's usually quite quick. So how to apply? We have a 3 steps procedure. So the first thing for you is to probably visit our website and check on the website. You have a specific page for the virtual access where we present the 3 services. We will tell you a few more details about the services afterwards, but you can find some information. And then probably the best is to get in touch with the service manager and to discuss with him all the details of the service provided, and for instance, try to identify the parameters that you would need to use, and check with him if everything you need is available. Then the second point is to complete the application form and send it back to the MaRINET2 Virtual Access Coordinator, who actually is myself. So, but you can send your application at the email address that is given here, marinet2_tna@ifremer.fr, and I will proceed with your application and send your request to the service manager so that it can provide the data or the service in time. So you can see on this slide, you can see the template of the application document. So you see that the information that is requested is really limited. So we ask some details: name, affiliation, position, and country of work. This is mostly for the statistics that are required by the European Union on the use that is made of the data sets, but it's the only information that is requested for these statistics. They don't ask us to assess the actual use that is made of the data, and you don't have to provide any, I would say, scientific outcome that you could obtain using these data sets or services. So the second information that is to be provided is the details on the hosting service. So which virtual access service you are actually requesting. Please enter here some details about for instance, the parameters you would like to use, the duration or the area you would like to use, or if it's a software, the different options you would like to use in the software. Please also indicate the dates and duration. So the start date at which you would like to use from which you would like to use the service, and the period over which you would like to access the service. And finally, we ask you to provide a few lines about the main scientific objectives of use of the virtual access service. But this just need to be really detailed, just for us to know what you're going to do about the data. As I said, the requirements when using the services are very limited. We don't require from you that you provide any specific reporting on the use of data or the service. The only requirement will be for you when benefiting from this access, as for any access to any of the MaRINET2 services, whether it is virtual or transnational access. We only require from you that you acknowledge the access to the service in any publication or document presenting the results obtained using the service. We just ask you to write in the acknowledgement these 2 lines of text indicating that the results have received funding from the European Union Horizon 2020 Framework Program and the grant agreement that is given here, which is the grant agreement corresponding to the MaRINET2 project. So I think that's it for this presentation about the virtual access service. I don't know, maybe we could, Amy, take some questions, if any, before introducing the 3 services, OMER, WinBench, and Skifeya.
Yeah, we do have a couple of questions, so I'll put them to you now, and then you can continue to talk about the OMER database. So the first question that I have for you, Christophe, is access to the virtual access platform possible beyond the MaRINET2 project duration?
Yes, I think so, Chris. Once you have access to the service or to the data, I mean, I don't see any limitation for this, at least for the data sets. Regarding the WinBench platform, I'm not sure you can have access to the platform itself after the end of the project. I don't think so.
Okay.
Even though it's because otherwise it wouldn't be. I mean, the access is being funded by the European Union, so it has to cover the. It has to be over the duration of the project itself. Yeah.
Okay. Okay. And is there a maximum duration for the use of data? So obviously people can apply for access over different time periods. Is there a cap on how long they can access it for?
No, we haven't defined any limitation for that. Actually, for a data set like OMER, the Wave Hindcast database, you can actually upload the whole data set if you want and then use it afterwards.
Okay.
It wouldn't be the same for the platform, for instance, and probably for Skiferia, but Lars would tell us about that afterwards.
Yeah. Okay. And we have another question, which is, is commercial use of the data allowed? So are there any restrictions in terms of the use of the data?
No, there are no commercial limitations. The limitations will be discussed with the service manager when you apply. But normally there shouldn't be specific limitations as it is part of the virtual access program.
Okay, so as long as it's acknowledged properly, then
yeah,
you can do what you want with it. Okay.
Yes.
And then I have one last question before I let you carry on, and it's does this virtual access service have any worldwide data, or is it limited to data in Europe?
At the moment, the HOMER database only covers the Bay of Biscay and the Channel. The Windbench facility is mostly for testing software, so it's in a way it can be used worldwide, I would say. And the Skiferia Met Station is a local Met Station, so yeah, it's mostly I mean, it's really local.
Yeah.
We don't offer any worldwide database at this stage.
Mm-hmm. Okay, great. Thanks very much. Shall I let you carry on then, and you can talk a bit about the OMER Wave Hindcast database that's offered by OMER.
Thank you, Amy. So a few words about this OMER Wave Hindcast database. So this is a database that was built at Ifremer in 2013, and it was built running the Wave model WaveWatch 3. It's, as I said, it's a Wave Hindcast database that covers an area that covers the Bay of Biscay and the Channel all the way up to the south part of the North Sea. You can see actually the computational grid on the slide here. So the model was a specific configuration of WaveWatch that in really parameterized for this area. We have considered different forcing fields. We've used for the wind, we've used the CF Survey analysis produced at NCEP in 2010. We also introduced as forcing fields the water levels and tidal currents. So they were composed from the harmonic components that we built from a data set that was computed using a specific model, which is called MaRINET2 which is a hydrodynamic model, so that we have we take into account the interaction, the wave current interaction in the process of wave propagation. The computational grid is an unstructured grid. It's really high resolution. We have over 100,000 nodes, and so you can see that the scale, the size of the mesh is well, about 10 kilometers offshore, and it goes down to about 200 meters near shore, so that we have a really refined mesh in intermediate waters, which is usually waters or areas of interest for offshore renewable energy. So as I said, the model extends from the south of the North Sea to the north of Spain and covers all the continental shelf in the Bay of Biscay and extends a little bit forwards to the west. The duration of the database covers 23 years, starting in 1994, and we actually try to extend it every year, adding 1 year every year. So I'm not sure the year 2017 is available yet, but it should be. If not, it should be available soon. And the time step is 1 hour. So as output available in this database, you can find all the global parameters like significant wave height, peak period, energy flux. We have altogether 37 parameters at each point of the refined grid. At each point of this grid, we also have the sea states partitions. So that is the component associated with the wind sea and up to 5 swells. So for these, we have the global parameters, HS, peak period, mean direction or peak direction, directional spreading. And we also have the frequency spectra, the 1D spectra, again at each point of the computational grid. Well, it wasn't possible to save the 2D spectra at each point of the grid, but we have developed, as output, we have developed a coarse grid with over 4,000 points at which we have saved the directional spectra. So you can have these directional spectra. They are provided on the. It's a coarser grid, but it covers the whole area covered by the model, and so it's still quite dense, I would say. And of course, all this well, the model and all the data has been validated against in situ measurement, altimeters, and other reference handcast datasets, such as the NOAA's dataset, for instance. Yeah, you can find some details on this on the elaboration of this wave handcast database in the paper that is referenced here on this slide. But I would be happy to provide you any details about this if you need. And yeah, I think that's it for this presentation on Homer.
Okay, thanks a lot, Christophe. We have got a question for you that's come in about the Hindcast database. A couple more coming in now, so I'll just put those to you. Are the forcing wind and tide data also available, and if so, at what time steps?
Yeah, they are available. They have been interpolated on the grid at the 1 hour time step. So all the forcing fields are also available. Yeah.
Okay, great. And then another question, which I think you've maybe already touched on, is this wave database available during the whole duration of the project? So I think this comes back a bit to, obviously it's available up until the middle of 2021 when the project finishes.
Yeah.
But I think you said that it was downloadable, so I suppose once
exactly.
Up until that point, the data can be downloaded as a set and used beyond that point.
Yeah, you can. I mean, you can use it past the duration of the project, and if you need it, you can upload either just the data sets that you need, or potentially you could also upload the whole data set. It's about 5 terabytes altogether.
Mm-hmm.
So yeah, it is available for upload.
Okay, perfect. And we've got another question that's just come in asking, is there an extension of Homer to long-term forecast of the climate evolution?
Something associated with climate change over, let's say, 50 years or 100 years. Not as part of this project.
Mm-hmm.
No. that wouldn't be part of the virtual access service.
No, okay.
We will probably develop other databases, hindcast databases, but that would be part of other projects.
Okay, so it might be available in another way,
yeah.
but not through the MaRINET2
exactly,
service.
Yeah.
Okay. Okay, thanks. That's all the questions I've got that have come in at the moment. Obviously, feel free to keep asking your questions as we go through. If you think of a question for Christoph later on, then obviously we can put it to him after the next presentation. So I'll pass over now to Javier Sanz Rodrigo and Pavel Gankarski, and they're joining us from the Spanish National Renewable Energy Centre, and they're going to be presenting the wind benchmarking service, which is offered again through the MaRINET2 project. So Javier and Pavel, if you're both with us, then we can start your presentation. And again, I'd encourage people to ask questions as we go along. We'll have time to put questions at the end if they're not picked up in between the presentations.
Okay, thank you, Amy, for the introduction. So my name is Javier Sanz, and I will present you WindBench, which is a service we've been running for a while, related to verification and validation activities and benchmarking services in particular. So I will present this together with Pavel, who's been the main developer of the system. WindBench was created to store repositories of validation benchmarks in principle. And we've been running this since 2011 alongside the IEA Task 31 Workbench, which is creating a framework for the national collaboration around wind farm flow modeling and model evaluation. And this is kind of an umbrella that has gathered a number of European and national projects. And essentially, in all these projects, there's been different activities related to flow model validation. And what we've tried to do is to bring some consistency across all these activities by offering this service where we can have all these benchmarks documented and have a kind of a simpler way of processing data and running the validation in a more or less consistent way. So what we call WindBench version 2 is available in windbench.net, and what you can find there is a content management system which provides this documentation for repositories, and we also initiated an inventory of models, so model developers can describe their models and categorize them in terms of predefined tags that inform users about what kind of modeling these models are able to run, what kind of code they have, what kind of fidelity, and so on. So that was an initial WindBench service, which is still available. Includes also, of course, the description of the validation test cases as well as the benchmarks that are included in each test case. So a test case is typically an experiment, and then a benchmark is a subset of the data extracted from the experiment, which is targeting some kind of validation objective. So it could be related to a specific physical phenomena that you want to test your model against, or it could be a full year type of data set where you are trying to see whether your model can reproduce some quantity of interest for an application. It could be annual energy production or any other design parameter. So these are some examples you can find in the windbench.net site, and they've been, of course, only related to wind energy, but we are not restricted to just wind. And MaRINET actually offers the opportunity to extend the scope of all this to other renewable energies in the offshore environment. So we really welcome any participant in the renewable energy space. Just to give you an example of how we are doing benchmarking nowadays, this Gables 3 benchmark is coming from the boundary layer methodology community. It's about atmospheric boundary layer modeling, and what you could find in the WindBench site is a description of the benchmark. So really the instructions for the modelers on how they should be running this case, which is a diurnal cycle in Cabau in the Netherlands. So it's a very canonical case that allows modelers to test how they are dealing with the atmospheric boundary layer running across different states of surface cooling or heating. And the status of this benchmark, of course, is already finished. And as you can see, we provide links to not just the observational data from KNMI in this case, but also the simulation data from the participants of the benchmark, as well as the evaluation scripts that were used to produce the benchmark results. Of course, normally you will end up publishing all of this in a paper. So that's kind of the process as you go. But the important thing is that you are able to find all the data that allows you to reproduce the benchmark results. So summary of the outcome. The simulation data, which we store in the EUDAT data management system. So this is a European project that is still alive, and then you can use it to publish simulation data. The evaluation script is something we share through a GitHub repository, and essentially allows people to run the benchmark results in the same way as you find it in the paper. And we try to publish this in Zenodo because Zenodo has this good integration with GitHub that allows you to have version control and on the scripts, as well as having a DOI link, so you can have the script reference in journal papers or any other material. So this is really kind of the overview of how we see a good benchmark being published so that it can be traceable. And now Pavel is going to describe what's going to happen when we integrate this into the virtual research environment that MaRINET2 is developing. So Pavel, if you can take the word now, describe.
Yes. Yes. Good morning, everyone. So yes, what you can see right now, it's these are all sorts of services that are available both outside of the MaRINET, but also inside of the MaRINET. So there's some data storage. There's a CData Cloud service that is being developed, and so on and so on. So I understand this is quite complicated, but this is how we implement the full workflow. This is how we work. Of course, the part that you'll be working with is much easier on the eye. So this is more for us. But anyway, I still think it's interesting. In the next slide, can you change that? So in this one doesn't get that much into the detail of the services that we use, but this gives an overview of our workflow and how we work with the dataset. This is not extremely different from the typical workflow that you all work with, but we have introduced some changes to improve the quality of the datasets produced in the experiment or produced during the benchmark exercise. So first of all, when processing the raw data, we use open source data converter, which also makes use of a variables dictionary. What that means is that the whole process of processing data, it generates data sets that follow naming conventions, that follow standards, that follow best practices, and it's also a process that can be repeated. Of course, we provide support to all that software. It's actually very easy to use. It's, I mean, the reason for using those converters and the variables dictionary is to do something that is relatively time-consuming normally, but with the support of the software, it's much simpler. There's also a data checker that checks the outputs, that checks the compatibility of the outputs from the data converter with the MaRINET2 official standards. The data checker was developed by Ipremer. And then in the last step, we move focus to where the science is. So we make sure that we focus on the data sets, not on the deliverables or the final article that only talks about the data. So what happens is that we make sure that the data sets are being published, that the data sets are being citable. Also, we make sure that they are well documented, and we also help with providing the Jupyter notebook that Javier presented before. So that way, those Jupyter notebooks, they don't just explain the data set, but they also become a tool that can be used later on. So if somebody wants to use the data set in a different way, you can just use the Jupyter notebooks, make some changes, and they will work. Then, of course, the last part with the metadata card, what that means, we get back here to the idea of publishing data sets. It means that the data set will be citable, so anyone will be able to cite specifically the data set, and they will also be findable in external search engines, and some statistics about citations will be built, and so on and so on. So that's pretty much it. I'll pass back to Javier.
Okay, thank you, Pavel. Just to give you some examples of benchmarks we are currently running under the IEA Wind umbrella. This is coming from the European Wind Atlas experiment, where you have a LiDAR mounted on a ferry and traversing the southern Baltic Sea. So it's a very nice case for mesoscale models to see if they can reproduce the profile across this large transect. So all this is normally documented in a benchmark guide, and we are now using the WindVane block, which is very straightforward to use and allows benchmark managers to provide information to the benchmark participants on how they should be running their simulations, so that the results in the air can be easily compared. Benchmark is from the US, from the Atmosphere to Electrons program. This is based in Texas. The Swift facilities are scaled, let's say, turbine laboratory, where they ran this experiment on wake steering. So you could with a nacelle-mounted LiDAR, they could measure the wake at different distance downwind, and then now we are running a validation case to see whether the wake models can reproduce this dynamics. Example, this one comes from industry, actually. It's from the Offshore Wind Accelerator in the UK. So we are testing wake models for array efficiency prediction, and the idea here is to see whether models that industry is using, how are they comparing to each other, in the prediction of array efficiency, which is really the main factor in design of an offshore wind farm. And in this case, we are even able to provide some sponsorship opportunity. So that's maybe something you could consider if you're trying to reach out to the wider modeling community. You could try to see if you can attract their attention with some sponsorship opportunity. To summarize, if you plan to run a benchmark using WindBench, this is the process you would typically follow. Of course, you should first apply through the MaRINET2 application for virtual service, and then you could use your own blog or website, but we can also offer you the WindBench blog to describe your benchmark. The input data is something you will have to prepare, and normally we share it through the cloud using B2 Drop, which is one of these UDAT services, or it could be Dropbox or anything you have available. Then normally we will take care of reviewing your benchmark guides if the process you propose is okay, and then provide you technical assistance on setting up the benchmark in the Jupyter Hub environment. We'll try to see whether your data complies with the data management practices of MaRINET2, and also we can discuss with you about access rights in case you are managing private data or public data. Normally you then have that published, and then you invite participants over to the, normally with a webinar just like this one, and this webinar can be recorded and posted in the blog, and it becomes very useful for any additional participant that could come later on. That is when you would use your evaluation script in the GitHub repository. You could do this privately within your benchmark community, or you could directly use it as a public repository. I would encourage you to share this because it's really how you can get other people to review what you're doing, and they can give you feedback on what kind of plotting would be useful, and so on. So it's really important that you share that as soon as possible, so that you can also allow the participants to use the script and test, for example, that the data format is the right one, so that you don't need to do that, to take care of that for them. So yes, then the participants should normally submit their formatted data. At MaRINET2, we have some standards for NetCDF that you could use, and normally there will be an output folder that allows people to upload their results, and the benchmark manager can use it to test the evaluation script. So yes, as you get this published, then people can run the evaluation scripts and test with their own data and decide which simulation results to submit in the benchmark. And normally this takes a few iterations. So maybe you would want to start with a blind test, but even if that is kind of an ideal benchmark, it's typically the case that you will need some iterations, because just by code-to-code comparison, you will be able to see whether you have some good interpretation of the benchmark. So it's typically through different iterations that you have everyone happy with the results, and then you can maybe compare that with observations. So that's how we tend to do the benchmarking process. And then, of course, Ceneris could be supporting you all the way. We are not, in principle, running the benchmark. That should be a benchmark manager that does the work. But we can always guide you through the process and give you some hints on best practices we've come up with. And then, of course, our objective is that you publish your results using FAIR principles. I guess you know about this. Is data should be findable, accessible, interoperable, and reusable. So this is really all about making your data standardized and published using accessible repositories. And for that, we have the MaRINET2 guidance as well for your support. Just some conclusions. We are available in the virtual access service of MaRINET, so you just need to apply for it. We plan to use the MaRINET infrastructure, which will be ultimately running in the VRE CDataNet ecosystem. We'll be launching a pilot with that kind of ecosystem very soon, like in July, in relation to an European Witness experiment that we've run in Pamplona. And for now, this will be based in Ephemer Jupyter Hub, but the idea in the end is that we use the CDataNet ecosystem. In the meantime, you can always apply, and we can get started with setting up all those benchmarks. That takes time, so the sooner you start with this, the better. So with that, I turn it back to you, Amy. Questions?
Okay, thank you very much, Javier, and thank you also, Paul, for your presentation. We've got a couple of questions that have come in, so I'll just put those to you. We've got the first one is asking, with the wake models for wind, what LiDAR would you use, long range or short range?
Well, it depends on what you are trying to validate, if that is your objective. So if it's array efficiency for a wind farm, then you need to use long range, which can allow you to have measurements up to 6 kilometers or so. If you are more interested in turbine effects like induction zone or near wake, then a short range LiDAR will give you more resolution, and it will have to be installed on the nacelle. That's kind of how I see experiments being developed. Yeah. Okay,
perfect. And then there's a request that the GitHub link could be shared with the participants. So we'll be sharing the presentations and so on after the webinar, but I assume that's something we could include as well. Javier, would be that link?
Yeah, so we have a GitHub project for WindBench, which you could use to store your validation scripts, but this is not necessarily mandatory. You can just use whatever GitHub repository you have, maybe an institutional repository or your own user repository. So the idea is that the links will be available through your publications in the end. Of course, all these scripts can be shared, yes. At least we can for sure provide the WindBench link.
Okay, is that something we can send around, or is it better that they contact you directly to request it?
Yeah, both are okay. I can send that to you, Amy, and you can circulate to the webinar participants, or they can contact me. Mm-hmm.
Okay, no problem. I've got a more general question here that could be for any of the presenters, maybe for Christoph as the overall responsible for this, but there's someone that's wondering, is there data available for tidal currents, for example, for other renewables? And is there any more? And is there any other wave data that's available via the virtual access service?
No, via the virtual access service, we only have the tidal currents that we've used for the forcing of the wave model, and they are probably not. I mean, the grid on which they've been computed is probably not refined enough for what you might need for designing tidal turbines or for characterizing resource. But there exist other databases, but they would not be available through the virtual access. But if this is something we can discuss afterwards if needed.
Okay. Okay, wonderful. I've actually got another question for you from your presentation on the OMER database, which came in a little bit later, so I might as well put that to you now. Are there plans to extend the coverage area of the OMER database in the future?
We are actually involved in another project, and through which we're going to develop a new version of the database that will cover a larger area, probably from northern Scotland to southern Spain and further east as well. So, but that won't be available until probably 2022, probably. Yeah,
Okay.
late 2021 or 2022, and I don't know yet what will be the way of accessing this data set for everyone, if it will be totally free of charge or accessible via a structure like this virtual access service, for instance.
Okay. Okay, thanks. I've got a question now for Javier or Pavel about the WinBench service, which is, where would we find process documentation in report or guidelines format rather than as published papers?
That's a good question. We are in the process of documenting all this benchmarking process. This is something I scheduled for June, July. This is part of the wind energy model evaluation protocol we are putting together for the IEA wind. So the idea there is to provide guidance on how to do benchmarking, verification, for the wind community.
Okay. Sorry, what did you say in terms of when this would be?
So we are drafting that already, but the idea is to have that released through the year, through this year.
Okay.
It's an open source project where we are integrating all this documentation. There will be a dedicated website for it. We call it WEMAP, Wind Energy Model Evaluation Protocol.
Okay. Well, perhaps that's something we could at least include the name of that and a link if it's available, which it may not be, when we circulate the information after the webinar.
Yeah.
Okay, great. Okay, I don't have any other questions coming in at the moment, so I think it's time to hand over to Lars from the Norwegian University of Science and Technology. And Lars is going to be talking to us about the Skifir Met Station on the Norwegian coast and the data that's available from that via the MaRINET2 Virtual Access Service.
Hello,
Lars,
good morning. Good morning to you all from Trondheim in Norway, about here. And we can see Trondheim on this map, where we have NTNU, and out in the sea we have this island Frøya. And on this island Frøya we have a Met station that belongs to NTNU. And on this Met station we can show this hardware summary, where we have masts, 100-meter high masts, and in one of the masts we have 6 pairs of 2D sonic anemometers at these heights above the ground, and also independent temperature measurements at the same heights and near the ground. And we have a Met station, also an official Met station, where we also can measure or have the local pressure and relative humidity, which is needed for the calculations of stability. On this island we have dominant wind directions. We have wind from northeast, where we get a quite large fetch to the Met station, but we also have southwest direction, which is a dominant wind direction. And this means that to some extent we can consider the measured wind at this Met station as ocean wind. The data resource is, because we have time series measured at 1 Hertz at 6 heights, giving us 2 horizontal velocity components. We don't have the vertical velocity component. And we have a database, which is from November 2009 to December 2015. And from this time series, there are processed data, such we had the 10-minute mean data, which is available for you at this certain website at Zenodo. So those are 10-minute mean data with also temperatures, pressure, and humidity, such that stability calculations can be performed. We also have 1 Hertz data time series, which is not put on this website yet, but those 1 Hertz time series are available. If you write me an email, I will provide data to you. This is a screenshot from the Zenodo database that further describes the database and how you can access the data, and also a list of references, papers, giving more information about these data. If you decide to use this, I will like to ask you to follow the instructions made by Christopher at the beginning of this webinar. I think that is it from my side.
Okay, thank you very much, Lars. I'm just having a look at the questions panel now, but I don't have anything new coming in at the moment. So there's a last opportunity now to ask questions from the audience. So please do send those in the next minute or so. So just a reminder that the webinar is being recorded, and it will be shared with everybody in the next day or two. It'll also be available on the MaRINET2 website. I'd also encourage you to take a look at the website, which is being shown on your screen now, to review a little bit the virtual access services, and if you want to contact any of the facilities directly, you'll see that at the end of the description of each facility there's some contact details there, so you can contact Christoph, Javier, Lars, if you want to follow up in a bit more detail on any of those. So yeah, it's just on the marinet2.eu in the virtual access menu there. So I don't see any more questions coming in. So I think that's a good place to wrap it up in that case. Many thanks to all of our project partners for the presentations, and thanks to the audience for the questions and the interest that you've shown. And yeah, as I said, we'll be in touch in the next day or two to share the material from the webinar. Thank you very much, and everybody have a good day.